In the next 3 lessons we're going to look at the manufacture of ethanol. First of all, we're going to look at how ethanol can be produced from ethene, then from fermentation, and then we're going to compare the 2 manufacturing processes. So first of all, let's look at how ethanol can be produced from ethene. Okay, so in this process, ethene is going to react with steam, and before we go on, let's just make a couple of notes about, well, the ethenes come from the cracking of alkanes, which have come from the fractional distillation of crude oil. Now, both of these procedures we've looked at in a previous lesson. Now, before we go on, you'll notice that this symbol tells us that this is what we call a reversible reaction. That means the reaction can go to the right or it can go to the left. And so we need to choose conditions which will favour the forward reaction. Now, you'll notice that on the left of the equation we have 2 gases. So water is in the gas state here, it's steam. And so we have 2 volumes of gas on the left, but only 1 volume on the right. So in this case, the forward reaction will be favoured by high pressures. Alright, so we'll write high pressure, and typically that will be around 80 atmospheres. Now, the other important thing to consider when we're looking at reversible reactions is the temperature of the reaction. And in this particular case, this is an exothermic reaction. All right, so heat is given out when steam reacts with ethene. So you might think that the forward reaction would be favoured by lowering the temperature. But there's a drawback in this, because if we lower the temperature, then the reaction rate will also decrease. We actually want the temperature to be high so that we can increase the collision rate between the water molecules and the molecules of ethene. So there's a compromised temperature of 300 degrees Celsius, which isn't too high, but it's high enough to keep the reaction rate going. Okay, so we're going to carry out this reaction at about 300 degrees Celsius, high pressure, 80 atmospheres, and we're going to use a catalyst called phosphoric acid. One thing I'd like to mention about this manufacturing process in the context of your IGCSE, GCSE exams is that actually you don't really need to worry too much about the reversible reaction principles here, about what favours the forward reaction. What is necessary with regards to the manufacturing process is that ethene will react with steam at 300 degrees Celsius and around about 80 atmosphere pressure using an industrial catalyst called phosphoric acid. Okay, you just need to know these details. What is important, however, is that we remember that 80 atmospheres pressure, 300 degrees Celsius temperature, the cracking of alkanes, the process of fractional distillation all involve extremely expensive equipment. So when we're comparing the manufacture of ethanol using this process with, for example, fermentation, we need to remember that this involves very expensive equipment. Now, with regard to reversible processes, this is described here because in the extended paper we do need to know about reversible processes, and this is a good example. So if you want to find out more about those, then you need to go to the section on reversible reactions and reaction rate, and that will explain in more detail Le Chatelier's principle, which will help you to understand this. In the next lesson we're going to look at the process of manufacture of ethanol using fermentation.